Okay, this is a question from the work power and energy where we have been given with a mud wall. Okay, what is a mud wall? A simple wall made up of mud. Okay, let's say this is the wall. Okay, if this wall is given that, let me read out the question. A bullet of mass 20 gram is fired from a rifle with a velocity of 800 meter per second. That means a bullet is fired from a rifle. Let's say this is the bullet which is fired, right? So if this is the bullet which is fired from a rifle, right? And this bullet goes and hit this wall, right? And after it just, since this is a mud wall, it crosses through this wall, right? It crosses through this wall and it just come out into right side like this. Okay, now the question is that a bullet of mass 20 gram, so this bullet is having a mass is 20 gram, right? And it's also given that a bullet of mass 20 gram is fired from a rifle with a velocity of 800 meter per second. That means when the bullet is fired before hitting the wall, that means its initial velocity is given to you. That is, initial velocity is given to you. Initial velocity is given to you, and basically that is nothing but u. U is given as 800 meter per second, right students? U is given to you. Even here you can see M is given to you, that is the mass. M is equal to mass. Now when you can see this is in gram, you need to convert it into kg before going forward, right? Now after passing through a mud wall of 100 centimeter thickness, that means the thickness of this mud wall is 100 centimeter, right? Now velocity drops to 100 meter per second. That means when the bullet hits the wall and when it comes out, then when it exits the wall, the velocity identified at this point, we can say that velocity as here as final velocity, so which is nothing but v. V is 100 meter per second, right? So this is given to you. This is given to you. Now the value of V is given to you. We need to find the resistance just applied by this wall. What is the resistance applied by this wall to this bullet? This is the question. Okay, what is the average resistance of the wall? And you need to neglect the friction due to air. So that means whatever the air particles which are here, they are also giving some resistance to the flow of bullet. So just we can ignore this one, right? So we can simply consider the wall. What is the resistance applied by this wall? So let us say the resistance applied by this wall, we can say, let us say it stop the flow of bullet with a force, and that force is equal to F. Let F equal to the resistance or force, definitely it will be force by force of wall on bullet, right? And definitely this force is nothing, this force is nothing but this is applicable due to presence of this wall into the path of the bullet, right? I hope you got it. Now here you can see what is the work done during this interval from this travel. That means the thickness of wall is 100 centimeter. So in traveling this distance, the bullet need to cross this wall, and some work need to be done by this bullet. What is that work? That work is nothing but force into distance, right? Hi Sunil, hi Utkarsh. Okay, we need to speed up. Utkarsh, let me follow it. Sunil, you are saying कुछ समझ नहीं आ रहा. Okay, I will explain it. Okay, but someone is saying that we need to speed up. So let me speed it up. Okay, so here the work done by this work or the energy exhausted by this bullet in crossing this wall will be equal to force into distance, right? And what is the force which is given to you? That is the resistance by this wall. So just keep it as it is, and in place of force keep it as a variable, and in place of distance it will be 100 centimeter. So 100 centimeter is nothing but 100 centimeter nothing but 1 meter. We can write this as 1 meter, right? 100 centimeter is equal to 1 meter. So this is the total work done by this wall in stopping this bullet, or which the bullet need to overcome through this wall, and this amount of work need to be done just to cross this wall from approaching A and hitting it and exiting at B, right? Now you can see, according to the work energy theorem, the work done is equal to the loss in the kinetic energy. So what is the kinetic energy over at this point, and what is the kinetic energy at this point? That we need to calculate, and we will equate it with this to calculate the F, right? Hi Samarthwan. Change in kinetic energy, definitely. So this will be equated with this one. Okay, the change in kinetic energy, the change or the delta of the kinetic energy is equal to how much? This is equal to what is the energy into the beginning, that is half m u square, and what is the energy at exit, that is half m v square, right? Definitely the conservation of energy, you are right, Stardust. Okay, so here you can see half m can be taken as common, and mass is 20 gram. 20 gram need to be converted into kg, so we divide it by 1000 to convert this gram into kilogram, and into the bracket it's u square minus v square, u square minus v square, right? You can see this 2 cancelled out, 10 will be cancelled out with this 1000 into the denominator, and we have 1 by 100 and u square minus v square. So you just remember the formula a square minus b square, it's a plus b and a minus b. So instead of a plus b, it will be basically u plus v and u minus v, right? Hi Utkarsh, thank you. So here you can see 1 by 100 u plus b. What is u? U is the initial velocity, that is 100 meter per second. So just write it over here. 800. 800. U is 800. Put the value of 800 over here plus b. B is 100. Right? Then u minus b. That is 800 minus 100. So this will give you 1 by 100 into 900 into 700. right? You can see double zero will be cancelling this one, and 9 into 7, 6300. So 6300 joule of kinetic energy, or the change in kinetic energy, is observed, right? So according to this work energy theorem, we can see the work done is equal to this loss of kinetic energy, right? So that's why at this point we can say that this 6300 joule, that is the, that is what, that is loss of kinetic energy, right? This will be equal to how much? Equal to the work done. And what was the work done which we have calculated? F into 1, right? So this is equal to F into 1. This is in 1 is in meter, right? Now this is the work done. Now if you equate it, you can see the only variable with us is F, right? So F can be easily calculated as 6300 joule by 1 meter, which is equal to 6300 Newton. So 6300 Newton is the resistance or the force applied by this wall in into and stopping this flow of bullet. So that much of work need to be done. That means 6300 Newton, right? So that is the resistance applied by this wall, right? This is from ninth class. Yes, Stardust is from ninth, it's from 11th. Okay. So in both the classes you will see the similar things. Okay. Only a little advanced version will be observed into class 11. But yes, you can have this concept in 9 also, right? 9 and 11. So in this way we find it, the force applied by this wall is 6300 Newton. And the question which was asked to us, what is the average resistance of the wall? So the average resistance of the wall is nothing but 6300 Newton, right? So we can see some similar questions. Okay, suppose another bullet, maybe we can see another example. Okay, a force of let me take another one, a bullet from the same type of question I am trying to consider it over here. Okay. uh, yes, there is a separate question, we can take it, that suppose a question is that calculate the potential energy acquired by a 10 kg hammer when it is raised to a height of 10 meter. So this is very simple question. Potential energy is mgh. The mass is known to you, right? G is the value known to you, and it's raised to a height of some 10 meter. So potential energy can be easily calculated. So such questions can be solved very easily. Now just take some different examples. Okay. Yes, we can take this. A bullet of mass 20 gram is found to pass 2 points 30 meter apart in a time interval of 4 seconds. Right? Calculate the kinetic energy. Right? So definitely it's very easy. Kinetic energy is nothing but it's given that 2 points are in front of you. Okay. One is A, another is B. Okay, and it's given that a bullet of mass 20 gram, let's say this is again a bullet of mass 20 gram, right, is found to pass 2 points 30 meter apart. So the distance between these 2 points is 30 meter, right? Now into this case, what we need to find, let me zoom a little. Yes, these 2 points are 30 meter apart, and to cross this it will take a time of how much? 4 seconds. This is a question which is given to you. All this data is given to you into this question, right? We need to calculate the kinetic energy of the bullet if it moves with a constant speed. So, okay. So when the bullet just reaches this point, right, and from this point is moved towards right, and it crosses this point B, right? This is B. So from A to B, it takes some time, that is 4 seconds, right? So what we will do, we first calculate the velocity. Velocity can be simply calculated because you can see 30 meter. So velocity is nothing but displacement by time, right? What is the displacement? The shortest distance between A and B, that is 30. So 30 meter divided by the time, which is 4 seconds. So this will be coming as 15 by 2 meter per second, right? Now the velocity is calculated to you 15 by 2 meter per second. What is the mass given to you? Yes, Veranoros Rosario, yeah, welcome. So yes, this is easy question, perfectly caught. So, but we need to understand the concept underlying, right? And the mass is given to you. I'm quickly solving it. Okay, 20 gram. So tell me what is the weight in kg? 20 by 1000, right? Because gram to be converted into kilogram. Now this is the mass given to you. Now what will be the kinetic energy? Simple. It's very simple. Kinetic energy is half into m into v square. So what is the value of mass? Half into mass. Mass is 20 by 1000, right, into v square. What is the value of v square? That is 15 by 2 square. That is 15 by 2 into 15 by 2. So this will 2 will be cancelled out, 10 will be cancelled out over here, right? And this 15 into 15 is nothing but 225 divided by 400, right? 2 into 2, 4 into 100, 400. Hi Mahinder Chaudhary, hello. So this is 225 by 400, right? So you can simply calculate, and this will be the kinetic energy which will be simply coming to you, right? Now we will take some more questions. Let us take some example of a simple pendulum, the bob of a simple pendulum, right? So into that question, let me turn the page. Okay. So a bob is given to you. Question is that calculate the velocity of the bob of a simple pendulum. This is the simple pendulum and this is the bob. This is the mass of the pendulum. And this is just swinging from its mean position going to the extreme, then returning back, and then going to extreme to the right? So this is the concept of pendulum, right? Now calculate the velocity of the bob of a simple pendulum. Velocity of bob need to be calculated, and the condition given is that velocity at its mean position we need to find if it is able to rise to a vertical height of 10 centimeter. So that means from the mean position here you can see, from here to here you can see the vertical height. This is the vertical height. Okay, so the vertical height, if you are observing, that is equal to 10 cm, 10 centimeter. Then into this case we need to find the velocity of the bob of the simple pendulum. If v be the velocity at the mean position, that means if you are considering at this point, let us say the velocity is v, and from mean position here it's moving towards right, okay, like this. And let's say the velocity is v, let us assume it as v at the mean position, right? Then into that part we can say that the kinetic energy at this mean position, at this is the mean position, the central point. At the mean position, the kinetic energy will be equal to half m v square. This is the kinetic energy, right? Now you can see this kinetic energy will be equal to the potential energy at this point, because at this point there will be no velocity of the bob. Okay, because the bob is going to right and reaching to this top, and the velocity of the bob will be finishing over here. It comes to rest, and after that it changes its direction and then start coming back towards the mean position, right? So we can say that kinetic energy at this point is equal to the potential energy at this extreme point. What is the potential energy at extreme point? It's mgh, that is mgh, right? Hi Mahinder, thank you dear, thank you so much. I am little less concentrating over the chat, but don't worry, I'm happy to see you all. Okay, yeah, be connected. Sure, sure. Thank you so much. Thank you so much, dear. So mgh will be the potential energy. So you can see at this point only potential energy will happen here. Potential energy. Why? Because there will be no velocity of the bob. Because the bob is going to towards right, and at this position the velocity is equal to 0, and kinetic energy is simply converting into the potential energy, right? Okay, so perfectly fine. We can simply calculate half mva square equal to mgh over here, right? And v square is not known to us, so that's why you can m and m will be cancelled out, and v square is equal to 2 times g into h. 2 times g into h. We know the value of g, that is, let us take 10. We know the value of h, that is 10 centimeter. Convert it into meter, so this will be 10 by 100 meter, right? 10 by 100. Now you can see v is nothing but root over of this. I wanna see ts channel getting banned. Oh, this action was automated. Anyway, students, I think this session is fine for today now. So we can wind it up. I'm getting some messages. So thank you so much for watching. Let's be connected. Bye bye. Take care. See you.